Today we are talking about basic proportionality theorem. For that we are taking a triangle and we try to draw a line parallel to one side of a triangle, and we see that it divides the other two sides in the same ratio. So the triangle I have taken here is ABC, okay, and A prime B prime is the line drawn parallel to this AB. Let us watch this one. A prime Z is 1 unit and A to A prime is 2 units. Here this is 1 is to 2. Okay, these are 2 units here. And this side also, this is 1, B prime Z is 1 and B prime is 2 units. So 1 is to 2 this side and 1 is to 2 this side. And if you want to take the whole thing, you take it as 3 units actually. It is like B prime Z is 1 unit and BZ is 3 units. This side A prime Z is only 1 unit and AZ is 3 units. That's why they say the ratio is 1 is to 3 here like. So even if you change the shape of the triangle, the ratio does not change. This is 1 unit and here you have 2 units. And this is 1 unit and here you have 2 units. So if a line is drawn parallel to one side of a triangle, it divides the other two sides in the same ratio. Let us just change this ratio and watch once again. So I am taking here, here you have 2 units and this is 1 unit. 2 is to 1. B prime Z is 2 units and BZ is 3 units. And this side also, A prime Z is 2 units and AZ is 3 units. So the ratio is same. 2 is to, you can say 1, or this side also you can say 2 is to 1. But mind you, the whole thing is 3 here. Okay, that's the ratio. That's how this ratio 2 is to 3 comes. So what I want to suggest here is that if a line is drawn parallel to one side of a triangle, it divides the other two sides in the same ratio. And conversely, okay, if a line divides two sides of a triangle in the same ratio, then it must be parallel to the third side. By any chance, if the ratio is same, in which the two sides of a triangle are cut, then that line must be parallel to the third side. This is what we mean by basic proportionality theorem. Once again, let us change the ratio and observe this one. I take say 1 is to 4. So the whole thing is say 4 units, and if you see separately, B prime Z is 1 unit but BZ is 4 units. Similarly, A prime Z is only 1 unit, AZ is 4 units. So even if you change the shape of the triangle, it still remains the same. The ratio doesn't change. We are not talking about the length of the sides. It hardly matters. What matters here is the ratio in which two sides of a triangle are cut. So there are 2 theorems here. One theorem is basic proportionality theorem. If a line is drawn parallel to one side of a triangle, it divides the other two sides in the same ratio. And the converse of that is, if a line divides two sides of a triangle in the same ratio, then it must be parallel to the third side. So this is what we mean by basic proportionality theorem and the converse of that.